Today I want to explain you something about the non-variable stars, which I want to present it for one of our conferences. Now I will share my screen. Variability. One of the important questions when it comes to describing stellar objects is, are all them variable? The most common given answer is that all stars are variable, but only the amplitude makes the difference. In general, variable stars are in the center of attention of most scientific studies. Non-variability, it is important not to lose sight of non-variable stellar objects, as they are very much needed for calibrating absolute fluxes and radial velocities. Many photometric calibrations of the effective temperature and metallicity are based on galactic field stars. There are two main reasons for the neglecting of the variability of the individual stars. The first one is establishing non-variability on the basis of a photometric time series is not straightforward. And the second one is demand of such an object is apparently not very high. Constantly level of a time series is depending on frequency range, amplitude, noise level, wavelength region, filter, applied pipeline software, applied cleaning software, time basis of the observations, and applied time series analysis method. Kepler Space Telescope was a very successful tool launched in 2009 for discovering extrasolar planets and variable stars, until it was shut down in 2018 due to fuel depletion. In total, Kepler observed 530,506 stars during its time life. Kepler used two observing modes for its light curve generation. The first one is line cadence, LC, which is 29.429 minutes beams of 270 integration. And the second one is short cadence, SC, that is 1 minute beams of 9 integrations. Panzanetta selected all stars which have line cadence light curves available within the original Kepler mission. They did not consider about 2,000 short cadence light curves because they are only a very small fraction of the overall data set as next step. They removed all stars already known as variable afterwards. They investigated the location of the target stars in the Hertzsprung-Russell diagram. As shown in Figure 1, target star sample consists mainly of objects cooler than 10,000 Kelvin, with most stars being solar-type objects, including also a significant amount of objects on the subgiant and red giant branch. There are no involved intermediate and high-mass stars included. They use the Lamb-Scargill imperiodogram and the false alarm probability FAP to analyze the clean data sets of 138,451 light curves. Then use log FAP more than -2 for defining a star not being variable in the ranges of below 0.1 cycle per day, 0.1 to 2 cycle per day, and 2 to 5 cycle per day, respectively. Furthermore, they also calculated the standard deviation of the mean light curve to provide another parameter. In Figure 1, the log G versus log T diagram for the full sample of the investigated stars. The astrophysical parameters were taken from Berger et al. 2020. And the conclusion is, in total, 14,154 stars were found which fulfill the set criteria. These objects are mainly cooler than 7,000 Kelvin, populating the whole main sequence to the red giant branch. Thank you for your attention and see you next time. Bye.